Hi, welcome to Dr. Pat TV. In this section, we'll be looking at product and quotient rules. These are taking the derivative of a little bit more involved things, taking the derivative of two or more functions, formulas that are multiplied together. That's the product, because another word, math term for product is multiplication. And then quotient, that's another word for dividing. We've got a nice rule for when we have two functions or more dividing, we can find its derivative. Okay, without doing a whole bunch of algebra kind of thing. Before I get into this, I just want to kind of give a little bit of background in this first segment about the product rule. And one of the things I like to do is address a very common misconception that I see all the time when I'm teaching the class. And so I just kind of want to address it first and just have a little fun of different kinds of misconceptions that we may have, whether 3D visuals or even just working formulas and things like that. So just having a little fun there. All right, so the misconception I want to address here is a common misconception for students when they look at the derivative rule is thinking that we take the derivative of both of them at the same time. And so wouldn't this be great? I mean, wouldn't this be grand if I took the derivative and basically it was the derivative of each thing? So we're taking the derivative of two things multiplying, and wouldn't it be great if it would be two, just nice straightforward, do the derivative of each one? But unfortunately, it doesn't work. No, it doesn't come through for us. And I'm going to try and show you an example why. So I'm going to do something here. I just want you to kind of kick back, relax. Don't worry about taking notes. I'm just going to basically try and show you an example to prove it to you, or to show you an example where it doesn't work. Okay, so one of the things I like to do is take the derivative of this complicated expression. And the long way of doing it is I would multiply the first thing doing. I would multiply this 2x to the fifth through each of these terms, and I would get something like this. So that's not doing the derivative yet. That's just rewriting it, because that's always a way that we can do it. Now that I've rewritten it, when I take the derivative, just doing that basic power rule, bring the 12 down in front, multiply, that's where that 96 is coming from, and then so forth and so forth. So doing the long way, I know that I can get my derivative, and that's kind of setting the stage. So the long way, it works. It's just the long way. It's kind of easy right now because I only got one term multiplied through, but if it was something more complicated, it would be a long way. What we'd like to do is there a shortcut? Come up with a shortcut for this. And so, wouldn't it be great, again, if I could just take the derivative of each one? Wouldn't it be great? It would be so wonderful if that would work. And that's why I got question marks right here, because does it work? Well, if I were to take the derivative of each one separately, or one, both at the same time, I would get this thing here. And if I multiplied this 10x to the fourth through, we would get 280x to the 10th. But wait a minute, this expression on the left-hand side, try to do this little kind of shortcut where I take the derivative of each one at the same time, does not equal. They don't equal. The long way I'm comfortable with, this shortcut of doing the derivative of each one at the same time kind of thing, doesn't work for us. Oh shoot, that would have been so sweet, so nice if it did. But let's do some. Let's explore some more. If we can't do the derivative of both at the same time, how about doing one at a time? Okay, so I'm not going to do both at the same time, but I'm going to do one at a time. Sound like a Dr. Seuss kind of episode here. All right, so we've got our expression, and I'm just basically saying that I've got a 2x to the fifth out in front, and then I've got this other expression here inside the parentheses. Well, what would happen if I did them one at a time? If I took the derivative of the 2x to the fifth, leaving the other guy alone, just doing one at a time, and then I do the derivative of the inside part of that parentheses, that's where that 28 x to the sixth thing comes from, but then leaving the 2x to the fifth alone. So I'm doing the derivative of one at a time. And I know that it looks kind of complicated, but if we did multiplied through 10x to the fourth, and we multiplied the 2x to the fifth, and then we combine like terms, and wait a minute, that checks. That's exactly what we got before doing it the long way if we multiplied the 2x to the fifth through first. So what I'm trying to show you here in this example is, wait a minute, if we do the derivative one at a time, singly, individually, we end up getting the right answer. And so basically, when we're looking at it, we're going with doing it one at a time is the key theme here. So when I'm taking the derivative of two things multiplying, expressions multiplying, it's the derivative of f prime, doing the derivative of f, but leaving g alone, haven't touched g, and then leaving f alone and then doing the derivative of g. And so we got a little plus sign here. And basically we're finding out that works and it's a consistent pattern. Now if you go into some higher level math classes, you could actually figure out how to prove that that actually works symbolically without using specific examples or getting lucky with the examples that I did. But that's a higher level math class and I'm not going to go into it here. But I just basically wanted to show you an example of where it kind of comes from. Mathematicians, we play with these things. We try. Sometimes we fail. Or most of the times we fail. And then we try different approaches, and we come up with it. And then we go through the process of trying to prove it. And so that's what we math geeks do. So the key thing on the product rule here is that we're taking turns. It's just like being in kindergarten and sharing that swing. Just when you're doing the derivative of two functions multiplying, do the derivative one at a time individually. Okay, that's the start of the product rule and the quotient rule. We'll do some examples in the next episode and then get into the quotient rule. Thanks and have a good day.